Hi, my name is John.
And my name is Alice. You're watching Math Videos for Parents. We help you so that you can help your kid with math. And today we're going to tackle the distributive property. So, John, I see you have an array all ready for us. Do you want to just dive in?
Sure. So based on the picture we have an array that has 5 rows, as you could see here, and 6 columns, as you could see here. The question that we're trying to work with is, what's the product of 5 and 6? How many dots are in the array? What are some different yet equivalent ways we can write out ways to get to 30? So one of the ways is dividing up the array into smaller chunks, as you've seen in some of our previous videos. So I can, for example, divide or partition, whatever word you want to use. I could divide the array up like this to make it 2 smaller problems. I can break it up into a 2 by 6 array and also a 3 by 6 array. So I'm basically splitting up the 5 into a 2 and a 3, yet maintaining the number of columns. And this is at the heart of the distributive property. We want to take a problem and rewrite it in a way so that we break up one quantity into 2 smaller parts, but leave the other quantity alone for purposes of multiplication. And if I want to find the sum, I have 2 times 6 is 12, 3 times 6 is 18, and then if we add those together, I get out 30. There's also a faster way we can do this where we take the 2 and the 3. If I just add those together and multiply by 6, that's another way I can get out 30 by distributing the 6 to the 2 and the 6 to the 3 and adding up 12 and 18 that way. So if you worked with middle school level math before in distributive property, you might be more familiar with the arrow approach and multiplying and then adding. These are the same thing. This just gives you a visual conceptual understanding of why that works. Alice, what's another way you can break up the array to find the same answer?
Yeah, great. Thanks, John. Before I do that, I just want to mention one thing that struck me when you were explaining this is it's probably a valid question to say, looking at this array, why don't we just do 6 times 5, right? But is my understanding correct that what we're really trying to do is develop kind of the conceptual understanding of why, this is going to lead us to 30, because as you mentioned, like once you get to algebra, you're not going to have a visual. You're only going to see it that way. Is that correct?
Correct. Exactly.
Okay, great. Wonderful. So now I'm going to break up the array a different way. So I'll use a different color. What if I split it right here? So then I have this top array. It's going to be 1 times 6. This bottom array here, it's going to be 4 times 6. So I can write it as 1 times 6 plus 4 times 6. And if I just want to do a quick check here, never hurts to do a check. 4 and 1 does equal 5, so I know I'm on the right track. 1 times 6 is 6. 4 times 6 is 24. And that's also going to give me 30. And that is to be expected, because even though John and I split the array, broke up the array in different ways, there's still the same number of objects here. We obviously can't create or destroy mass in a word problem or in a visual problem here. So we better have both gotten 30 or we did something wrong.
Exactly. So in effect, what you basically did was you took the 5 and you broke it down into 1 plus 4, but you kept the columns the same. So you left 6 columns. So if we think of it using the old like arrow approach from middle school, we're really breaking it up into 6 times 1, which you did, and then 6 times 4, which you did, and then adding those results together. So it makes complete sense whether you look at it from an elementary standpoint or a middle school standpoint.
It's nice to be able to see both viewpoints, because it just makes the problem kind of come together in a richer way.
Right, and I think sometimes in middle school you're just told, here, you draw the arrows, this is what you do, but the reason for why we do it is rooted in arrays and being able to break up an array into different in different ways, different numbers of rows and columns to find the product.
Well, I, for one, find this very enjoyable. So let's do some more.
Sounds good. For our next example, we will take a look at area and distributive property. In our previous example, we looked at arrays, which are very closely tied to area. So suppose that I want to find the product of 7 and 8, but by using the distributive property instead of just recalling a product off the top of our heads. So I have the ability to break up this rectangle, the 7 by 8 rectangle, into two small rectangles. So suppose that I break it up as follows. I place a vertical line right here, and I sort of divide the 8 into a 3 and a 5. And that works because 3 plus 5 is equal to 8. Now, to find what the total area is of this whole rectangle that I have here drawn in black, I could take advantage of the distributive property. Instead of doing 7 times 8, I could say that this is equal to 7 times 3 plus 5. I took the 8 and I broke it up into two smaller numbers, 3 and 5, whose sum is equal to 8. Next, if I look, I'm a visual learner. I like to look at areas. If I break it up and try to do it using the visual, if I found the area of the small rectangle, that would be a 7 by 3 rectangle. And if I found the area of the bigger rectangle, that would be 7 by 5. I'll just go this way with my scribbling. So I would want to add that because together they make the whole shape. 7 times 3 plus 7 times 5. And I know that 7 times 3 is 21, and 7 times 5 is 35. And if I add those together, I get out 56. And one thing I want to show you is, in case you know distributive property from maybe the middle school level, you might recognize this step right away as distributing the 7 to 3 and distributing the 7 to 5. And I wanted to highlight that because of the area model. This helps us understand why we can draw those, arrows over from 7 to 3 and 7 to 5 and distribute 7 to both of those. 7 is the common width that both rectangles share. So our answer this way is 56. Alice, is there another way you can break this rectangle up to find the product?
Yeah, there's a lot of different ways. So I'm going to show another option. You might ask, why did John make that, put that line where he did? And that was just his choice. That's the beautiful thing about math, is there's a lot of ways we can approach it that are correct. So I'm going to put the line right there. So I'm going to say, okay, this is going to be 6, if you count these, and that there is 2. And that makes sense because 6 plus 2 is 8. So I can write this as saying, okay, 7 times 6 plus 2. And then I can handle what's in the parentheses first, which is going to give us 8, which is also 7 times 8 is going to give us 56. Or I could take advantage of the distributive property, and I could say, okay, I've got 7 times 6 plus 2. So that can be rewritten as 7 times 6 plus 7 times 2. And that's kind of intuitive because 7 times 6 over here, that's going to be, as John said, you can really look at the areas. That's going to give you that area there. And 7 times 6 is 42, which makes sense because if you counted up all the little squares in this rectangle, you get 42 of them. And then 7 times 2 is going to give you 14, which would be this area here, which would take less time to count because it's smaller. And then those numbers add up to 56. Wonderful, John. Any final thoughts?
I'm just amazed at how many different ways there are to solve this problem. Many equivalent ways to get the overall area using distributive property. And the beauty of it is these are just two. I mean, we could have broken the 8 up into 4 and 4 or 1 and 7. It really is, it's up to you. And distributive property is a third grade New Jersey student learning standard and skill that students learn. And it definitely carries them up all the way through middle school and high school. So if they're having trouble in middle school, perhaps you might want to show them this example from third grade to help solidify their understanding at a conceptual level.
Yeah, distributive property is something that, we're going to see again and again and again in our math lives.
All right, great. So thank you, everybody. Alice, you want to give information about our YouTube channel?
Yeah, we're Math Videos for Parents, so please subscribe to our YouTube channel. It helps other people find us. We also have a Facebook page, so please follow us there. And if you have any math problems you'd like us to address, please send us an email, mathvideosforparents@gmail.com, or, put something in one of our comments, and we can't wait to help you. Thanks so much.
Have a great day.